Get ready to take your learning to the extreme. Okay, so today we're learning about extreme values over an interval. It's just such an extreme topic. I had to start with an extreme intro. Anyways, so today we're basically using calculus and derivatives to look at a function over a specific interval and find where the absolute highest and absolute lowest y values are. So you might be thinking, well, duh, that just happens at the turning points. So we just have to find the derivative and see where it equals 0. And then that's the maximum and the minimum points. Well, sorry, folks, it's almost that easy, but not quite. See, extreme values can happen at points where the derivative is 0, but they can also happen on either end point of a function. Okay, I'll show you guys what I mean visually because visuals always help with math. So here's an example with what you're thinking about. So you start here and you go up, and then you go down, and then you end here. So this is your starting point, we'll call it A, and this is your end point, we'll call it B. And you can see that in this example, our max happens here, okay, where the derivative is 0, and our min happens here, where the derivative is 0. So cool, maybe that's what you were thinking of. But how about this situation? Okay, so what if we start down here, and we go up, and then we have our max, and then we go down, and we end here. So here's our A and our B. Well, here it's a little bit different because notice that our max does occur where the derivative is 0, but our minimum actually occurs at the end point, A, not at the turning point over there. Similarly, we can have something like this where we go up like this, and then we end up here. Let's a bit lower. So in this case, our min and our max are at the endpoints. They are not at all where the derivative is 0. So basically today, we're just constructing an algorithm for how to find those min and max points. So this lesson is going to seem kind of, I'll be honest, boring, even though it's extreme. But just trust the process because this algorithm is important because we will be using it in word problems from now on. So really this is just a baseline way of teaching you the algorithm, which we will apply to word problems. So the maximum value can occur at a peak. So for example, where the derivative is equal to 0, or it can occur at the end point, okay? A minimum can occur at a valley, so where the derivative is 0, or at the end point. So basically, our algorithm for finding those extreme values, the max and the min, is that first you find the derivative, first you find the points, you find the x values that make the derivative 0, then you take those x values and put them back into the function and see how high or low those y values are. Then you calculate the value of the function at the endpoints and see how high and low those y values are, and then you just compare. You pick the highest and you pick the lowest, bada boom, bada bing, you're done. Okay, so these are called extreme values, or they can be called extrema. All right. Okay, we're going to have some extreme fun now and actually do the algorithm. So let's take a look at this function. It's a cubic. So we can imagine that it's a downward facing cubic that will have a couple bumps in it, one bump here and one bump there. So we just have to see in the section that we're given, -1 to 5, are those bumps the highest and lowest points, or are the end points that we're given higher or lower than those bumps? So step 1 is to find the derivative. So aren't you glad we did that over and over last unit? Now it should just be easy peasy. So -6x squared plus 18x is our derivative. So now we want to find where that is equal to 0. So -6x squared plus 18x equals 0. Okay, so we can common factor out a -6x. And that's x minus 3. So therefore, at x equals 0 and at x equals 3, our derivative is 0, which means it gives us a horizontal tangent, which means those are the two bumps, the valley and the peak. So now we find f at 0, so that's back at the original function, and that equals 4. And we find f at 3, again, putting it back into the original function, and that gives us 31. So now we just need to go to step 2, where we look at the interval. So this interval is from -1 to 5. So we just have to see, does one of these x values give us a y that's either lower than 4 or higher than 31? So f at -1, if you put it into the function, gives us 15. And f at 5 gives us -21. So now let's take a look. Our lowest y value occurs here, and our highest y value occurs here, so we can make a conclusion. The max value occurs at the point 331, and the minimum over this interval occurs at 5, -21. Okay. All right, so now we can have like a basic word problem where this is useful. So again, here we have a cubic function that's downward facing, okay? And this gives us the amount of current. And we're just looking at the first 5 seconds, including 0 and 5. So we want to determine the times at which the current is at its maximum and minimum and determine the amount of current at these times. So we find the derivative first. So that's -3t squared plus 2t plus 21, and we want to set it equal to 0. Okay, and solve for t. So -3t squared plus 2t plus 21 equals 0. So now we can actually take out the negative number so that it's easier to factor, sorry. 3t squared minus 2t minus 21 equals 0. Okay, and so now you can factor that too. You can do your factoring techniques, and you get 3t plus 7, t minus 3. Okay, if you don't want to factor, you can use quadratic formula, and you'll get the solutions -7/3 and t equals 3. Well, we know right away that our first t value is inadmissible because it is not within our range or desired interval, so we won't include that. But this is a possibility. So now we want to find the current at 3 seconds, and that is 45. So now so that's step 1. Step 2 is testing the endpoints. So the current right at the beginning at time equals 0 is 0. And the current at the end of the interval, so for 5 seconds, is 5 amperes. So it said determine the times when the current is at its maximum and minimum. So we can say current is at min of 0 amperes at 0 seconds and max of 45 amperes at 3 seconds. And that's within the given interval. Okay. Let's do example 3. This gives us a function of the amount of light intensity. So again, this is why we learned how to find the derivatives of all different kinds of functions, because here we have a rational function. So we will need the quotient law to find the rate of change of light intensity. So remember, we're finding the derivative because we want to set it equal to 0, because that will tell us where the slope of the tangent is horizontal, which gives us a turning point possibly. Okay, so let's recall it's the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Okay, so when you actually, I trust that you can do this, you FOIL this, expand this, collect like terms, and you get t squared plus 4t minus 12 Is it quick? Someone's here. Is it quick? I'm recording. Yeah, that's fine. Over t plus 2 all squared. Okay, so there we have the derivative, and now we're going to set it equal to 0. So notice that we can just set the numerator equal to 0 because this will cross off with it. So we can factor this to t minus 2, t plus 6 equals 0. So t equals 2 is within our given interval of 0 to 14 seconds, but you'll notice that t equals negative 6, is inadmissible, so we don't include it in our calculations. Okay, so now let's find the light intensity, went all over the place, at 2 seconds, and that is 6. What is that? The amount? So 6, I guess that's 6. That's the level of intensity. It doesn't say the units. So then we check it at 0 seconds, and there we get 8. And we check it at 14 seconds, which gives us 15. So the minimal intensity occurs at 2 seconds. Okay, so you can write a nice little sentence there. The minimum intensity occurs at 2 seconds. Now, there is another way of doing this algebraically if you want to see a cool algebraic trick. It's on page 134 of your textbook if you feel like a little extension or just taking this to the extreme. All right. Okay, I want you guys to practice these two coming in because this is such a basic algorithm. I believe in you fully that you can figure this out and do it yourselves. So the extreme values for part A, you should get that your max is at 221 and your min is at 0.1. And for this function here, you should get that your max is at root 3, comma, it's like, I should have kept it in, it's 0.385. And the min is at 1, comma, 0. Okay, so there you go. You learned a new algorithm, and we will practice it tomorrow in class on these basic questions so that you will be confident going into the word problems. So thanks for watching, guys. Hope you learned lots.